This is question 36. So in this question we have a triangle PQR, which was shown here, with the angle QPR, so QPR here, which is 60 degrees, PQR is 45 degrees, and QRP is 75 degrees. We also know a side length, RQ is √6 units, and we want to find the length of PR. So there's a few ways we can go about this, but I think the quickest way would be to use the sine rule. Can you remember what the sine rule is? So the sine rule says that sine A over the length of A equals sine B over B. These A's and B's relate to the angles and sides of a triangle. So we can name them however we want as long as we're consistent. So if we call this angle big A, then the side little a is the one opposite this angle. So if this is big A, this is little a. And then if this is big B, this is little b. If this is big C, this is little c. And this is the formula which relates them. We could also use this the other way around, so we could have little a over sine of big A is equal to little b over sine of big B. It doesn't matter which way around we use it. If you're struggling to remember this as well, it's worth just thinking about this. This does actually make sense. Do you think of how the angles and the side lengths relate to each other? They are going to be related, so the bigger the angle here, the wider these two things come out, so the bigger this length will be here. Okay, so let's apply that in this case then. So we're going to do sine, we're going to call this our A, so sine of 60 divided by the length opposite, √6, is equal to sine of 45 over PR. We've chosen these ones because we know the angle and the side length here, and then of course we want to include the length which we're trying to work out, otherwise we're going to work out this one and that's not going to be helpful. So we choose this pair and this pair. So can you remember what sine of 60 and sine of 45 are? So sine of 60 is √3 over 2, sine of 45 is √2 over 2. So we substitute those into our equation here, and we're just going to rearrange for PR, which is √6 √2 over √3. Notice that √6 is the same as √2 √3, so the √3's cancel, and we get √2 times √2 on the top, which is just 2. So our answer is A. If you're struggling to remember what the sine of different angles are, you can draw out something which looks like this. So we're going to have theta is equal to 0, 30, 45, 60, and then we're going to have sine theta. And if we just put 0, 1, 2, 3 in here, then to find out what the sine is, say we wanted to find the sine of 30, so sine of 30 here, we take whatever's there, we square root it, and we divide by 2. So for example, if we wanted to work out the sine of 60, we take the 3 there, we square root it, and we divide by 2, and you can see that that is the sine of 60. We can also get the cos of theta as well for these values. So if we do it the other way around, so we could actually just put 4 in here and have a 90 degrees as well, then we just do 4, 3, 2, 1, 0, and we do the exact same thing. So we take whatever value links to the theta we want, square root it, and divide by 2. So that's just a quick way of working out the values if you can't remember them.